Hi, welcome to steptomaths. Today we are going to discuss about sum of first n terms of an AP. Generally, we can represent an arithmetic progression with first term A and common difference D is A and second term is A plus D and third term is A plus 2D, etc. The nth term of an AP is A plus n minus 1 into D. This is the general formula of an arithmetic progression with first term A and common difference D. Now, how we can find the sum of first nth term? That we can represent using Sn. The sum of these terms A plus D plus A plus 2D, etc. plus the nth term is A plus n minus 1 into D. The sum of first n terms of this AP, Sn. Next, revising this term and rewrite this, how we can express Sn is equal to, in this reverse order, that is first we can write the nth term. Nth term is A plus n minus 1 into D. And the second last term is, we can write it as A plus n minus 2 into D. So, the next term is A plus n minus 2 into D plus etc. The second last term on this reverse order, that is A plus D, and the last term is A. First we write in T1 plus T2 plus T3 plus etc. plus Tn, and second we express that expression in reverse order, that is Tn plus Tn minus 1 plus etc. plus T2 plus T1. Now add these two equations. The left hand side become Sn plus Sn. Sn plus Sn is 2Sn. Next is A plus on the second row it is A plus n minus 1 into D. If we add these two terms, A plus n minus 1 into D, that is equal to A plus A is 2A plus n minus 1 into D. So, when we add these two expressions, we get to Sn is equal to, the first term is A plus n minus 1 into D become 2A plus n minus 1 into D. The first term. Now consider the second terms of these two expressions. The second term is A plus D. So this A plus D plus second term on this expression is A plus n minus 2 into D. Add these two equations, A plus D plus A plus n into D, nd minus 2 into D, minus 2D. A plus A is 2A plus D minus 2D become minus d plus nd, or we can write it as 2a plus, if we take this d as common, d plus d into minus 1 plus or n minus 1. So when we add the T2 from first expression and T2 on second expression, we also get 2a plus d into n minus 1, we can write it as n minus 1 into d, etc. If we add the second last term, a plus n minus 2 into d plus ad, that is also a plus n minus 1 into d, and the last terms of these two expression, a plus n minus 1 into d plus a, that is also 2a plus n minus 1 into d. So when we add these two expression, the sum of first n terms of arithmetic progression, if we add the two expressions, we get 2Sn is equal to 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus etc. plus 2a plus n minus 1 into d. That means the right hand side n times, here n times. So these terms are n times repeated. So n times 2a plus n minus 1 into d. M times 2a plus n minus 1 into d. The left hand side 2Sn. Therefore, we can write the value of Sn as n is equal to this 2 on right hand side become upon n upon 2 into 2a plus n minus 1 into d. The sum of first n term of an AP with first term a and common difference d is Sn is equal to n upon 2 into 2a plus n minus 1 into d. Formula for sum of first n term of an AP. We can rewrite this equation Sn is equal to, if we remove the bracket, n upon 2 into 2a, n upon 2 into 2a plus n into n minus 1 into d upon 2, or we can write it as na plus n into n minus 1 into d upon 2. We can rewrite this same formula as Sn is equal to n into a plus n into n minus 1 into d upon 2. But generally we use this formula. Sum of first n term of an AP is n upon 2 into 2a plus n minus 1 into d. If we know the first term and the common difference, and then we can find the sum of first n term of an AP. Consider the question. Find the sum of first 123 even numbers. Sum of first 123 even numbers. That is the given question. Even numbers. So the first term is, first even number is 2, and we can write this arithmetic progression in the even numbers. So we can write it as 2, 4, 6, 8, and the sum of 123. That is n is 123. If the numbers are in arithmetic the numbers are even numbers, so the value of d is also equal to t. And formula for sum of first n numbers is n upon 2 into 2a plus n minus 1 into d. Here n is 123, a is 2, d is also 2. Now substitute as n is equal to n upon 2. N is 123 upon 2 into a is also 2 plus n is 123. 123 minus 1 into d is also 2. If we simplify this right hand side, we get the value of Sn. Simplify it. 123 upon 2 into 2 is 4 plus 123 minus 1 is 122 into 2, that is equal to 123 upon 2 into 4 plus 122 into 2, 244. Or we can write it as 123 upon 2 into 4 plus 244 is 248. We can cancel this 248. This become 123 into 124. Multiply 123 into 124. That is equal to 15,252. Sum of first 123 even numbers is 15,252. Here we use the formula sum of first n numbers in an AP is equal to n upon 2 into 2a plus n minus 1 into d. N means how many terms? A is first term in the AP and d is the common difference of the arithmetic progression. And if we substitute the values of n, a and d, we get the sum. How we can find sum of first n natural numbers? We know the equation sum of first n numbers in an arithmetic progression Sn is n upon 2 into 2a plus n minus 1 into d. Using this equation, how we can find sum of first n natural numbers? First n natural numbers. So the arithmetic progression is natural numbers is 1, 2, 3, 4 up to n. First n natural numbers. The equation Sn is equal to n upon 2 into 2a plus n minus 1 into d. N natural numbers. A is first term. A is equal to first term is 1 and then value of d. D is also equal to 1, 2, 3, 4. That is the arithmetic progression. So d is also 1. N is n. If we substitute the value n upon 2 into 2a. 2 into a is 1 plus n minus 1. D is 1. If we simplify this, n upon 2 into 1 is 2 plus n minus 1 into 1. That is n minus 1. If we simplify this, we get n upon 2 into 2 plus n minus 1. 2 minus 1 is 1. 1 plus n. So the sum of first n natural numbers is Sn is equal to n upon 2 into 1 plus n. Sum of first n natural numbers. N upon 2 into 1. Actually 1 is the first term of this arithmetic progression and n is the last term. So we can rewrite this equation as n upon 2 into first term plus last term. Sum of first n natural numbers is n upon 2 into first term plus last term, that is equal to n into 1 plus n, we can write it as n plus 1 upon 2. If we know the equation n into n plus 1 upon 2, we can find the sum of first n natural numbers. If n is given, directly we can substitute the value of n and find the sum of first 10 natural numbers. Sum of first 10 natural numbers. On that case, the value of n is 10. So we can directly find the sum of first 10 natural numbers is 10 into 10 n plus 1. N plus n is 10. So n plus 1 is 11 upon 2. 10 into 11 upon 2, that is equal to 55. Without applying this equation, we can directly find the sum of first 10 natural numbers using this equation n into n plus 1 upon 2, or generally we can write it as sum of first n natural numbers is n upon 2 into first term plus last term. Thank you.